Okay, so we are group 9. That's Yemi. He's going to be drawing the solutions on the board. That's Andrew. He's also going to be drawing the solutions on the board. And I'm Scott. So the problem we were doing from the book is 8-23. Basically, we have this setup. We're given this distance as just A. And what we want to find in this problem is that distance A, knowing that the slope here at big A is equal to 0. To do this, we're going to be using the method of superposition. We have both our different beams set up here. For number 1, we're just going to be assuming this force here doesn't exist, and we only have this force. For number 2, we're going to assume we only have this force over here, but not this force. Okay. So for part 1, first thing we're going to do is find the reactions using statics. When we do the statics, we find that AY is equal to P over 2. And it's symmetric between points A and B, so we also know that BY is also equal to P over 2. Alright, so now that we know the reaction forces, we can draw the shear diagram. We know it's positive between points A and C and negative between points C and B. The max of this diagram is at P over 2, and the min of this diagram is at negative P over 2. Alright, now we have the shear diagram drawn, we can then draw the moment diagram. This diagram is symmetric between points A and B. The max of this diagram is equal to PL over 4EI. Okay, now that we have the moment diagram drawn, we know it's positive for all points between points A and B. And that tells us the curvature of the beam is pointed upwards. So using that information, we can draw the deflected shape of the beam. Now, what we want to find is theta of A. I'm going to write theta A. We know at point C, since the moment diagram is symmetric, at the midpoint between A and B, which is point C, we know the slope is 0, meaning that theta A is equal to theta A with respect to C. So theta A with respect to C is just equal to the area under the moment diagram between points A and C, which is just equal to L over 2 times PL over 4EI times 1/2. And when you do the math, it's just equal to PL squared over 16EI. Should we stop this and then do the other thing? All right, fine. All right. So now we're going to move on to the second part of this problem, which assumes the other force is present and the force between A and B is not there. So first off, we use statics to find the reactions again. When we do that, we find that AY equals P plus PA over L, and BY is just equal to PA over L. All right. Now that we have those forces, we can draw the shear diagram. The minimum value of that diagram is equal to negative P, and the maximum value of that diagram is just PA over L. All right, now that we have the shear diagram, we can also draw the moment diagram. And the negative value of this diagram is just equal to negative PA over EI. Okay, now that we have the moment diagram drawn, we can come back up to the beam and we can draw the deflected shape of the beam. We know that the moment diagram is negative for all points, so the beam is concave down for the whole thing. Now, we also want to find theta A again. Now, since the moment diagram is not symmetric, we can't, it's not as easy as in part 1. But we do know that the length between A and B times theta A is equal to T of A slash B. Now, if you want to just do the math over here, that eventually sums up to theta A equals T of B slash A divided by L, which makes the hardest part of this problem just finding T of B slash A. So, if we want to find T of B slash A, we just take the centroid of the moment diagram between points A and B, which is just 2/3 L. So back up here, T of B slash A equals 2/3 L times the area of that triangle below the moment diagram, which is just negative PA over EI times L times 1/2. So when you do the math for T of B slash A, it's just equal to PAL squared over 3EI. Now to find theta A, you just divide that by L. You can probably do that under that. So theta A is just equal to PAL over 3EI. Okay, now we're done with superposition. We know the angle for each one. Now the method of superposition just states that we add these two together and that will give us the result. So coming over here, if we want the angle to be equal to 0, we just do theta A1 plus theta A2 is equal to 0. Now, theta A1 is a positive angle and theta A2 is a negative angle, so we just set them equal to each other. So we get PL squared over 16EI equals PAL over 3EI. And we want to solve for little a. So he's going to do the math up here. And then it just shows that a equals 3/16 of L. Yep. And that is our solution. Have a nice day.